Hello, everyone. I'm Tracy Derwin, and I'm here with Shane Buell. In today's video, we'll be analyzing the crash of Air India Flight 171. This went down on June 12th, leaving Gujarat, India, headed for London. There were 241 on board who lost their lives and 38 on the ground that did as well. It hit a building which was a medical school dorm. So the casualties from this were pretty significant, and there was one lone survivor. So Shane is going to be going into detail on these things. So thank you, Shane, for bringing this information up, and I'll let you present this information.
All right. Thanks, Tracy. So many of you might not be familiar with the fact that back on June 12th, a Boeing 787 crashed shortly after takeoff in Ahmedabad, India. And like she said, 279 people had lost their lives, which includes 241 who were on board. However, there was actually one survivor. And I will show some of that video here. So there was video that was captured of the survivor. He's in a white shirt. He comes walking out of the alley there where you see the smoke and the flames. And so, yeah, he had crashed and he was seated in seat 11A, which is right next to an emergency door. The plane split in half and his half of the plane fell on the ground. And he actually climbed out of the emergency door and walked away from the wreckage, which is quite miraculous. A lot of people have a hard time accepting the fact that someone could survive a crash like that. And there are a lot of conspiracy theories going around. Some people say he jumped out of the plane before it struck, but that's not actually true. I have some footage here of him saying how he got out of the airplane.
And how did you jump from the aircraft?
I'm not jumping.
Okay.
I just walk out, innit?
Okay.
Then ambulance coming in.
You did walk out on the building or?
No, in floor.
On the floor.
Yes.
All right. And that was 40-year-old Vishwash Kumar Ramesh. And he was a British national who was returning to London at the time. All right. So he definitely did walk out of the airplane. He didn't jump. Now, everyone has been speculating online, and I've been trying to hold back my own speculation. And so I'm not really going to speculate here or propose a cause of the crash. I'm just going to present possible causes and how likely I think they are. I will also eliminate some of the causes that people have been speculating as well. I do want to show the first video that I actually saw on this crash was from Juan Brown. He has a YouTube channel called Blanco Lirio. And he had the first video that I saw on this, and he had been flying his own private plane that day and just had taken a second to look at the videos that were circulating. And within 2 minutes, he noticed something that almost no one else had. And so I'm going to play that video here.
It's Thursday, the 12th of May. Just got word of the 787 crash in India. Looking at some preliminary video at this time. This is the first big crash of a Boeing 787. This is going to be a very important aircraft accident investigation. We do not have a lot of information or data at this time. What I want you to do when you look at these videos is try to figure out a couple of things. One, is there high enough resolution video where you can see if the ram air turbine is deployed? Is the rat deployed? Two, look at the landing gear sequence. Look at a normal landing gear sequence for a Boeing 787, and then look carefully at this accident sequence, the condition of the landing gear. Remember, when the gear retracts on the 787, it starts with the bogies tilted back like this, then the inboard doors begin to open, and then the bogies start to tilt forward, and then the gear retracts up into the wing. What is the condition of the bogies, and what is the condition of those gear doors? In other words, was the gear retraction sequence initiated and then interrupted, or was the gear never raised in the first place? Good luck sorting through all the fluff that's out there on the internet right now.
All right.
And Shane, really quick, the official story is that it was pilot error. Is that the most
That's not
common?
the official story. That's just the most popular story at the moment. And I will actually get into how that occurred and actually how that was retracted as well. So the person who actually made that statement has actually retracted it and changed their mind. All right. So yeah, Juan Brown of Blanco Lirio channel, he gave me a little bit of homework to do. He said to look for the rat, the gear, and the flaps. And so that's what I did. And I did find a better quality video of the crash on Vaz Aviation. And he actually has a high quality video where you can hear the rat deploying. All right. So that noise that you heard that sounded like a propeller plane passing by was actually this little like outboard propeller that drops down and it spins up to generate emergency power. And that only happens in the loss of full electrical loss or a dual engine failure. And it's looking like we could be looking at some sort of dual engine failure. So I had seen that video and had, made auditory confirmation that the rat had deployed. And that video was actually good enough that you could even see it as well. However, this is Captain Steve's YouTube channel. He went on national Indian TV and had postulated a theory that the pilots could have flipped the flaps instead of the gear. So this is what the gear retraction lever looks like. It's way up high on the dash and it looks like a landing gear. And the flap lever is actually down next to the pilot on the console and it looks like a flap. Not only that, we also have proof that the slats were extended and proof that the flaps were actually configured correctly. So Captain Steve had gone on Indian TV and said that he postulated that it could have been pilot error. And that got millions of views. And that's all the talk of India right now. And it looks like they're going to try to pin this on Air India so that, Boeing doesn't take the fall for this. I do want to play Captain Steve's video because after I had seen the rat from Vaz Aviation was very clearly deployed, I actually linked it to Captain Steve and showed him, as I told him, you can hear it very clearly, but you can also see it as well. And so he made a follow-up video.
Some new video has emerged that's changed my analysis of this accident in particular. And so I thought maybe it was simply they grabbed the wrong handle and prematurely raised the flaps. I was leaning heavily into that. I'm going to change my analysis now because of this new video. Right there, my friends. Take a look. We've circled it for you. Now, a lot of people have been talking about the theory that the rat had deployed. What's a rat? It's a ram air turbine. The rat is basically just behind the wing on the right side of the airplane. There's a little door that holds it in, and it looks like a little Evinrude motor. It's a little two-bladed prop, and the purpose of the ram air turbine is to provide electrical and hydraulic pressure for the aircraft in an extreme emergency. I think this was a dual engine failure. I'm firmly in that camp now.
All right. So we can visually and auditorily confirm that the rat had deployed, indicating either a system-wide loss of electrical power or a dual engine failure. So we've covered the rat. Now I'm going to go through the gear now. So I do have a picture of the landing gear, and this is from Air India Flight 171 on its final flight right before crash. You can see that the landing gear with the wheels on the gear, also called the trucks or the bogies, are actually tilted downward. The front wheels are actually lower than the back wheels. And that is what happens when the gear is selected in the up position. I actually have some video of another Air India 787 taking off, which I'm going to show you here. And you're going to see that as it lifts up, the back wheels start out in a downward position just in case it touches back down. But then when they select the gear up, the front wheels tip down before it retracts the landing gear into the landing gear bay. So we can see from that photo that the landing gear were pointed downwards, which means they were actually selected up, but the retraction cycle was interrupted. And it was probably interrupted either from an electrical failure or a dual engine failure. All right, so now I want to talk about some of the other theories that have been floated out there. Right away, there was a lot of people saying that according to the ADS-B data, that the aircraft only used half of the runway. That's actually not true. They taxied onto the middle of the runway and then went all the way to the beginning of the runway before they turned around, and they used the entire runway. It's almost 2 miles long. Another theory that had gone around was bird strikes. It is possible that if you had a flock of birds, both engines could have ingested a bird. However, there were no bird remains that were found on the runway or anywhere around there. And there was no flocks of birds that were seen in the videos, although they were low quality videos. However, the engines were also inspected, and aside from the impact with the building, it doesn't look like it had ingested any birds. So it looks like a bird strike can be ruled out, especially because if a bird were to have flown into an engine, you would see like a puff of smoke or even a small flame shoot out the back of the engine. We didn't see any of that. All right. The next thing that people had proposed were fuel issues. The main theory at first was fuel contamination, but fuel contamination would have affected more than just one airplane because they do refill those airplanes from a common tank. Another issue related to the fuel would have been vapor lock had been proposed. And I don't think vapor lock is, not only is it highly unlikely to happen in these jet airplanes with their compressed fuel lines, but a dual vapor lock is almost impossible. So I could see maybe a single vapor lock happening, but a dual vapor lock is virtually impossible. The other fuel issue that had been mentioned had to do with the fuel shutoff valve. Now, I know Gary B. Pilot on YouTube had mentioned that the fuel shutoff valve could spring close in the event of a power loss. However, when I looked into it, it's actually a mechanical servo that remains in its previous position when it loses power. So it was also not the fuel shutoff valve as well. All right, so the next thing I have here is the density, altitude, and or a compressor stall. So it was very hot that day, and hot air is actually less dense. And the air that day would have been, I guess they say it was 40 plus degrees Celsius, which is like 110 plus degrees Fahrenheit. According to that, air density at ground level was equal to the air density of 3,000 feet, which means that it would have had a lot less lift. And some people say that could have caused a compressor stall. So when the plane goes to rotate and actually tip the nose up to take off, it tilts the engines a little bit, and the airflow coming into the engines is at more of an angle, and I guess at a lower density. You could possibly have a single compressor stall, which to me is very unlikely, but the idea of a dual compressor stall is just absolutely unheard of. And the, I guess, remaining issues have a little bit to do with some of the airworthiness directives, which were issued by Boeing regarding the 787. Ever since 2015, they issued an airworthiness directive for all the Boeing Company 787s, which requires repetitive cycling of the airplane electrical power. This airworthiness directive was prompted by a report that the stale data monitoring function of the Common Core system may be lost when continuously powered on for 51 days. And so that has to do with the power being on continuously for 51 days. And then there was this other airworthiness directive that was also issued. This AD requires repetitive maintenance task for electrical power deactivation on the Model 787 planes. This was prompted by the determination that a Model 787 plane that has been powered continuously for 248 days can lose all alternating current electrical power due to the generator control units simultaneously going into failsafe mode. So if it's been left on for 51 days, they can run into problems. But if it's left on for 248 days, they can also run into problems. So at first, it looked like this could have been a potential, reboot in midair. There was also a comment on another YouTube channel. This is really long. I'm not going to go into it, but I'll show it here so that you can pause it and read it if you like. It talks about these airworthiness directives and how they have nearly caused issues in the past. And it has a lot to do with these airplanes being powered on continuously for a long period of time, and one of the system components not being able to compensate. Now, they had said, okay, well, we're just going to reboot. We're going to turn it back off and turn it on every so often. And it's unclear whether Air India had kept up on those maintenance schedules or not, but it's really not a robust design on the part of Boeing to rely so much on its redundancies. All right, so that brings us to the FADC and the EEC issue that I want to talk about. The first video that I'm going to show regarding this is from Taking Off, and here's what he has to say about it.
What investigators are looking deeply into right now is the FADC system, and so far, not much has been discussed about this. Okay, for non-pilots, the full authority digital engine control, FADC, is a dual channel computer controlling each GEnx engine powered by engine generators, the APU, or batteries with weight on the wheels. WOW is what they call that because everybody loves a good acronym. FADC runs in ground mode. At takeoff, a WOW switch shifts it to flight mode for the climb. A faulty transition could disrupt thrust, potentially spooling the engines back to idle thrust after the WOW shift. But dual FADC failures are rare due to built-in redundancies. They'll be looking at electrical corrosion or other possible interferences with the electrical system feeding the FADC computer.
All right. So I think that this is something that we should actually pay more attention to, the full authority digital engine control, which is part of the electronic engine control system. We've seen that, Boeing has all these various faults and everything, which can, interrupt power flow to different parts of the plane. However, this full authority digital engine control came up and I thought it was really suspicious. And so I kept looking into it and I found another channel called Beyond the BS. And we're going to hear what he has to say here.
If both engine generators fail mid-flight, the rat deploys. Within seconds, it starts delivering around 30 kilovolt amps, just enough to keep the backup bus, the CACs, and transformer rectifier units alive. Once the APU spins up and takes over, the rat retracts automatically. That transition typically takes about 1 to 2 minutes. On paper, Boeing's electrical power architecture should never cascade into a total failure. Yet there is one exceedingly rare edge case: simultaneous FADC protect idle. In certain DC side faults, both FADCs, one to each engine, can perceive a loss of power and command engines into protect idle, which is about 8% of max thrust, designed to protect against overspeed or surge. And when does this happen? Aviation engineers invoke the Swiss cheese model, where multiple unlikely failures must align to breach every layer of defense. But the available information, in my opinion, point toward a catastrophic electrical anomaly. Landing gear was extended. It's normally raised above 100 foot, the rat deployment indicating both engine generators went offline. No visible engine damage beyond impact scars, video evidence of thrust rollback but not an engine out explosion. Taken together, this sequence, the rat thump, the engine spooling to idle, and inability to retract the gear could be explained by that very edge case we just discussed. A full AC generation failure followed by a brief 28 volt DC sag, tripping both PMA and DC channels on each FADC and forcing protect idle fuel schedules mid-takeoff. And this could be from any number of electrical issues, such as a transient high load sag. Of these, the most likely scenario is still a real dual sag. From there we get the rat automatically deploys in under 2 seconds when both main AC buses drop. The deployment bang matches the lone survivor's report. The engines, idle thrust still provides a few thousand pounds, enough to carry the climb to 600 feet before drag overcomes lift. And the gear with engines idle, hydraulic and electric pumps lose their motive power so the crew couldn't retract the gear. Is it likely? No. It's the first recorded Dreamliner hull loss in 14 years of flying. But under an extreme Swiss cheese alignment of electrical faults, both FADCs could be forced into protect idle, producing exactly the observed flight profile.
All right. So a dual FADC protect idle seems to be one of the more likely scenarios that could have possibly happened here, at least in my opinion. Now, I'm not a pilot. However, I do have some experience with flight simulator. Back in the late 90s, I wanted to be a pilot and an astronaut, and I did spend, a lot of time in flight simulator. And I also went to space camp, so I do know a lot about space shuttle operations as well. So I'm not like eminently qualified to speak on this, but I do have some knowledge. And I do think the dual FADC protect idle situation is probably the most likely scenario that happened. But what could have caused that? It had to have been some sort of transient voltage or a fault where an electrical line might have grounded out, or something else that interrupted the power flow to the airplane. When I see this tail section, the paint looks fine and the structure looks mostly intact. So when I first saw this, I was actually relieved that the black boxes might likely be intact as well. However, they do claim that the flight data recorder has been burned up, and this is a picture of it that does show it as black and charred instead of the normal orange that it should be. And they are sending the black box to the United States to be decoded because the AAIB in India was unable to extract the data from the device. So now it goes to the United States, where Boeing And the NTSB, the National Transportation Safety Board of the United States, will be trying to extract the data from the black box. I do find it highly suspicious that the black box was burned up because it's built to survive in 1100 degrees Celsius heat, which is over 2000 degrees Fahrenheit. Now, I did look up the temperatures at which kerosene or even JPA burns at, and there's a wide range. So a lot of people say it could be anywhere from 450 degrees all the way up to 4000 degrees. So it's possible that it could have burned up in the fireball, but when I look at the tail section, I don't see a lot of fire damage. The paint looks intact, and there's not even a lot of structural damage either. So I do find that to be a little bit suspicious. And in my opinion, Boeing has no incentive to retrieve the data from that black box, in my opinion. All right. So now that brings us to some of the other possibilities. Now, I am fairly confident that there was some sort of electrical failure, but what actually caused the failure? Was it a bare wire? Was it a transient load? Was it a power surge? And one thing has to do with radio waves. So there was an AD that was prompted by a report of multiple instances of loss of transponder for airplanes entering airspace in the presence of continuous wave interference. It entered an area of radio interference and it interfered with the transponder. Now, they also tell people to put their phones in airplane mode before the airplane takes off. And I used to not think much of this, but then when I have looked deeper into this, it looks like both radio waves and 5G can interfere with more than just the transponder on a Boeing 787, but they can also interfere with other electrical systems. So it's possible that it could be radio waves or 5G. However, I did want to include one more possibility that really no one else is talking about. Now, I'm not saying definitively that any of the things I've mentioned today are guaranteed to be like the issue, but it looks like it was an electrical problem, and the electrical problem had to have been caused by something. It is also susceptible to radio and 5G, 5G being a form of microwaves. Now, this is from 1994, and it has to do with a remote vehicle disabling system, which involves an electromagnetic pulse. This is a compact, transportable electromagnetic pulse to disrupt electronics controlling the operation of a target vehicle. And that was in 1994. However, today, we actually have anti-drone rifles, which are actually rifles that are handheld that can emit an electromagnetic pulse. But we also have this company called Eperis, which actually has just recently joined Palantir's Warp Speed to accelerate the production for defense and commercial markets. Eperis is the developer of Leonitis, a high-energy, high-power microwave technology to counter drones, drone swarms, and electronics. And they do use the Palantir operating system. So I wanted to go and show you some footage. So this is the Eperis Leonitis, which is the next generation attack for precision fires, whatever they mean by that. So these are Leonitis pods, which are nicknamed Phaser 1 and Phaser 2. They're compact, mobile, high-powered microwave systems. These pods, you see them going up against other drones, but they are also able to take out vehicles as well. And they are depicted here taking out a truck. So if they can take out a truck with the vehicles, the electrical system in a truck, they could also theoretically take down the electrical system in an airplane. And these were actually deployed in 2022. So back to you, Tracy.
So, when I heard about this, and initially they said it was pilot error, just looking at like overall who they would pin this on and what the costs for who was responsible for this, it would seem like it would be the easier way to blame the pilots. First of all, they're no longer with us. They wouldn't have to look at any kind of faulty equipment, and they wouldn't have to consider an external pulse or EMP or something like that, right? Which is a lot more complicated than just simply saying the pilot pulled the wrong lever. So, my hypothesis is they're going to say that the black box, couldn't be fully recovered, or they couldn't get the information out, and they're just going to blame like user error, which is really sad because the pilots are not here to defend themselves. And this mistake that they're talking about, if you really look into it, it's not something a seasoned pilot would have done, right? Even a rookie
Right.
pilot probably wouldn't have, I mean, that's a really big mistake, right? To pull the wrong lever. And if they were to blame the structure or the way the plane is manufactured, that would be an extremely costly problem, because they would have to go back and get all their 787s and potentially, redo them or recalibrate them, or do some major restructuring to the craft, right? If it was some sort of internal glitch or problem like that. Also, the fact that we have so much more 5G, so many more people have phones, and not everyone turns off their phone or puts it on airplane mode. It would be a bigger problem as well. They would have to change FAA regulations and, maybe prevent people from bringing their phones on, because the process of checking everyone's phone and making sure it's on airplane mode is a huge time. It takes a lot of time. So I'm guessing they're going to go with the theory that the pilot made a mistake, which is really sad, because they're, tarnishing their reputation, and they're no longer with us to defend themselves.
Right.
So it's really sad that that's kind of how things work. Whatever the cheapest, easiest answer is often what the officials go with. And I think they did fire management, right, with Air India.
Yes, they actually have put pressure on Air India to remove, I think, 3 of their human resource managers. And it's basically because they think that they've been like overworking the pilots, because they're assuming that this is pilot error. And so then they're saying, well, look how long of hours they've been working the pilots, and then, human resources get in trouble for that. So they want to fire someone and hold someone responsible, but they have to find out what actually happened first. And I don't think it was pilot error.
But that's what we're seeing with these events, is like, find someone that's at fault, make them resign, or, fire them. Okay, problem solved. Let's move on.
Right.
It's kind of what we're seeing, which is not a good way to prevent these from happening again. And we have been hearing of these 787s having electrical problems since this crash, right? They haven't crashed, but they've had some kind of glitches.
Well, so they've reported, there have been several flights that have reported technical glitches, but they haven't actually said what those glitches are. It hasn't resulted in any crashes, but it has resulted in the grounding of, several flights. Air India has actually grounded or canceled, perhaps, I think, over 60 flights that might be related to technical issues.
All right. Well, it's also, putting people that aren't responsible for such a horrible loss of life. And I didn't know about the medical students that were also affected. That's really terrible. And, I know in the US, you're not supposed to have like homes or businesses within the flight path. Like, there's a certain rule that, you can't, because that plane was only in air for what, a few minutes?
Half a minute.
And they were so close to, medical school. That probably is a problem as well, and it was in India. Maybe it's just they don't have that they don't have those regulations, I'm assuming.
Well, yeah, who knows? It's a much higher population density, and maybe they just have too high of a density for those kind of regulations, or maybe they just have different building codes altogether. I'm not really sure.
Yeah, that's really sad that they were probably medical students, right?
Yeah, they were.
Yeah, young people just starting out their lives. So I you know what, they haven't really mentioned that they lost a significant amount of medical students.
Oh, yeah, 38. I think 38 people on the ground. Yeah.
Yeah, that's a really huge loss for a lot of people, a lot of families.
Yeah.
Okay, so thank you, Shane, for digging up all this information. And leave a comment if you have an idea of what you think really happened. So that's going to do it for today. Thank you guys so much for being here, and we'll see you all soon. Bye.